Hi everyone, today's our lesson is the differential equations, basic definitions, the differential equations of first order and separable equations. In the mathematics and physics, we can often meet problems where and we need to solve an equation containing not only an unknown function and its argument, but also the derivatives of unknown function. The equation of kind f x y y prime y2 prime and etc. y power of n equal to 0. And the equation contains independent variable x and the decided function y of x depend on x, its derivatives y prime, y2 primes, y3 primes, and etc. is called ordinary differential equations. The order of the highest derivatives occurring in the differential equation is called the order of differential equations. Is here the highest order derivative is y power of n's order. It means that the equation nth order differential equations. For example, the equations plus xy minus x squared equal to 0, x prime squared plus xy squared prime plus y squared equal to 0. The equation is called first order ordinary differential equations. If we give these forms of differential equations plus x squared y prime plus n f function of xy equal to 0. These forms of differential equations called second order differential equation because the highest order of differential derivatives is second order. For this reason, these forms of differential equations called second order differential equation. A function, if any function y equal to here x is called a solution of the differential equation at the interval a to b. If substituting into these equations implies an identity for all x from this interval if x approaches to these intervals. For example, the function is solutions of ordinary differential equations at the intervals at this interval. So we need to check it. Okay, let's start. Which types of differential equations called first order differential equation? The equations in the forms. If we give equation in this form, in the general, here x is independent variable and y is the unknown function. The unknown function. F is given function of these three variables. Let's consider the partial case of differential equations. If we are solving an equation with respect to derivative, we get these forms of differential equations, and its differential equations called a first order equation resolved with respect equation. The first equation calls a first order equation resolved with respect to derivative y. For the equation is here the function f. For function f, we can write two conditions. First condition, path f x y function must be continuous in the domain D of the plane x in the domain D. And the second condition is its partial derivatives for any variables f y and f x should be existed and it should be bounded in D. Okay, let's start. M1 y dx plus m2x times m3 y dy equal to 0. These forms of differential equations called separable differential equations. To solve these forms of differential equation, firstly we need to separate variables. To separate that, we need m1 times m2, and is here we obtain m1 m2 dx and m2 dy equal to 0, and is here gives in this form separable differential equations. To solve this equation, we need to integrate and for every variables and can write general solution equal to integrating of 0 for any variables. We can write here or dx or dy, and is here we can bring x plus f of y function equal to c, and it calls general solutions of these forms of separable differential equations.